Today, first of all, the Common Core really is FBF, which stands for Functions and Building Functions, okay? So what we're going to be doing is building functions. So we're going to take a function and we're going to redraw it, okay? So if I take a look, first of all, in example 1, it has little directions. It says take the function plus 2, make every x value plus 2, and every y value minus 1. So really what I'm going to do, take the entire thing, this is a translation, and move everything over 2 and down 1. So let's just take every important point, and the important points are the ones that are easy to find. Let's take every single one, take this whole entire graph, we're going to move it over 2, down 1. It's that easy. We're just going to scoot it over 2 and down 1 because of the plus 2 and the minus 1. So it should look something like this. You get a different color. Oh, I need a good color. All right, brown will work. So I'm going to go over 1, 2, 1 for that point. I'll take this point over 2, 1. I'll take this point over 1, 2. Hold on. 1, 2, 1. 1, 2, 1. Missed that one. There you go. 1, 2, 1. There we go. It's looking like that. And then the rest of it goes up like this. 2, 1, 2, 1. 1, 2, 3. Okay. Okay. So I took every point, I just moved the whole graph over 2, down 1. Can you see that? And if you need to do it point by point, you can. This point 2, 1. This point 2, 1. This important point 2, 1. This point 2, 1, 2, 1, 2, 1. And you can do it point by point. Or some kids are really good at actually just seeing the whole thing. If you can just see it, move it over 2, down 1, awesome. Okay? Pretty easy. Do you see what I did? Just took this graph and just moved the entire graph over 2, down 1. Alyssa, you ready? Take this point over 1, 2, 1. There it is. Okay? Take this point over 1, 2, 1. There it is. Take this point over 1, 2, 1. There it is. Connect the dots, right? And you do that every single point, okay? Okay, example 2. Okay, g of x is shown in the graph reflect over the x-axis. So this is my x-axis. So I'm going to reflect it, okay? The way I'm going to reflect is this. So this piece right here, this piece is going to come down there. Phones better be put away. This point right here is on the x-axis, so obviously it's not going to be flipped anywhere. This point, which is down 1, 2, 3, will now go up 1, 2, 3, right? This point, which is down 2, is now up 2. This point, which is down 1, is now up 1. Slide across a couple. This point, which is up 1, is down 1. 3. Okay. Can you visually do that? Okay. There it is. And I just did it point by point. Went up 1, now down 1. I went down 3, I went up 3, okay? I went down 2, then I went up 2, okay? Just flipping over. I went down 1, so I flipped it up 1. I went down 1, so I flipped it up 1. This one here is up 3, so I went down 3, and that's the easiest way to draw it, okay? Just take every single point and fold it over, okay? Okay, example 3. P of x shown in the graph reflect P of x over the y-axis, right? So I need to put it over the y-axis. So I'm going to go that direction. So here's how I would do it. I would say, since we're going over the y-axis, I could go back 1, 2, 3. So the opposite to go over the y would take it, go over 1, 2, 3. So that point would be there. This point is back 1, so instead of going back 1, I'll go forward 1. Okay, so you see that little piece right there? Folds over there. It's got to go down to 0, right? I know that point's there. This point, which is over 1, now is going to go back 1, right? I'm just doing the opposite. Over 1, back 1. Okay, this point is over 2, so I'll reflect it. So going over 1, 2, I'll go back 1, 2. And then I will go 1, 2 like that. Right, do you see my reflection? So I'm just doing the opposite. If I go to the left one, I'll go to the right one. If I go to the left 3, I'll go to the right 3. That takes me a reflection of the y, okay? Is that good? Thumbs up? Easy? Okay. Turn the paper. Right now, we've got it in terms of f of x. Makes it a little bit different, okay? So first of all, how do we graph a parabola? Please listen. We can do a t-table. We're going to graph a parabola like this every single time. And I want you to watch, because I do this in all my classes. In fact, if you just had me for geometry, we did this. 0 squared is 0. 1 squared is 1. Watch my hand. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9, right? Because I'm doing an x squared equation. Negative 1 squared is positive 1. Negative 2 squared is positive 4. Negative 3 squared is positive 9. So watch. So x squared, right, starts. The vertex is at 0, 0. So let's start at 0, 0. So let's do that t-table in our head. Let's just do a t-table in my brain. If I go over 1, 1 squared is 1. So I'll put a dot there. Go back to the vertex. If I go over 1, 2, 2 squared is 4 because I'm doing x squared. So I go up 1, 2, 3, 4. If I go back to my vertex, I go over 1, 2, 3. 3 squared is 9. So I'm just doing a t-table in my head. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I know that the negatives will be the same because negative 1 squared is a positive 1. Negative 2 squared is a positive 2. Negative 3 squared is a positive 9. It makes a parabola, doesn't it? And that's our parent function, what we call our parent function. It's called our parent function. And our parent function is the basic. It is the basic x squared. Now, the reason we call it parent function is because we're going to do different things to it. We're going to change the parent function. A, we're going to make it twice as tall. We're going to take the parent function. We're going to take this graph right here. We're going to make it twice as tall. In the next one, we're going to take the parent function. We're going to make it half as tall. Okay. On this one, we're going to take it and flip the parent function over the y-axis because the negative out in front of here. So that's why it's called the parent function, because it's the basic graph, and now we're going to change it. Okay, so let's do A. 2x. What we're going to do is make it twice as tall. So again, 1 squared is 1. Twice as tall would take me to 2. 2 squared is 4. Twice as tall would give me to 8. 3 squared is 9. Twice as tall would be 18. Let me do that. So again, the vertex has got to be at 0, 0. Okay, I'm at 0, 0. All right. If I go over 1, 1 squared is 1, but let's make 1 twice as tall, which puts me to 2. You want me to do that again? Do that again? Okay, normally I go 1, 1 squared is 1, but now I want to go twice as tall because of the 2. So instead of go 1, 1, I'm going to go 1, 2, twice as tall. Go back to my vertex. 1, 2. 2 squared is 4, right? 2 squared is 4, so 1, 2, 3, 4. But I want to be twice as tall. So instead of going to 4, let's go to 8. 4, 5, 6, 7, 8. 1, 2, 3. 3 squared is 9. I have to go twice as tall, but that's off the page, right? You guys agree? Too tall. So I'm not even going to put it on there because it's too tall. It's way up here, okay? Way up here somewhere like that, okay? Now, of course, it's symmetrical, isn't it? Negative 1 squared is 1, but twice as tall is 2. Negative 2 squared is a positive 4, but I want to go twice as tall as 4, so I go 4, 5, 6, 7, 8. And of course, negative 3 squared is 9, but twice as tall is 18, but too tall to be on the graph. So if I compare this graph to the parent graph, they're the same shape, aren't they? Except for this one's twice as tall. You could say it's skinnier. I'd go along with that. But I really want you to say it's twice as tall, okay? Does that make sense? It's stretched, right? All right. Example B. So instead of twice as tall, let's make it half as tall. Yeah, Austin.
For question A, wouldn't it be 2fx squared?
Ah, great. I like your questions. What is f of x? Fx is the x squared, right? So since fx is the x squared, you take the x squared, so it's 2 times x squared. Okay, what is f of x? It is x squared, so we really are graphing 2x squared. Does that make sense? Okay. Now, in this case, I wrote it as 1/2 x squared, didn't I? So you see the difference. Still the same kind of problem. 1/2, half is tall. So, normally I go 1, 1, 2, 4, 3, 9, right? 1 squared, 2 squared, 3 squared. We got that, capiche? But instead of going 1, 1, now I'm going 1, 1/2. 2, not 4, but 2, 2, half is tall. 3, not 9, but 4.5, half is tall. So let's do it. 0, 0 is my vertex. If I go over 1, I would go up 1, because 1 squares 1, but I'm only going to go half of that. Half is tall. So then I'd go back to my vertex and go 1, 2. 2 squared is 4, right? 2 squared is 4, so I'd go up 1, 2, 3, 4. I'm going to go half as tall because of the 1/2. So to go up 4, I'm going to go to 2. Okay? 1, 2, 3. 3 squared is 9, right? So I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9. But I don't want to go to 9. I want to go half as tall, which is really 4.5. 1, 2, 3, 4.5. Okay? Now the nice thing about a parabola is it's symmetrical, right? So I know the other points have to be here, here, and right there. So it seems as if it's wider, right? And it does appear wider, and that's okay to call it wider. But the truth is we just want to call it half as tall, okay? It is indeed wider than the parent function. If you compare it to its parent function, it looks wider, but the truth is we're just going to say it's half as tall, okay? Last one, okay? The negative out in front. If f of x is y, it's really like saying negative y, right? Well, if the y's are up and down, if we want to do negative, we're going to go down, right? So let's take our parent function and let's make it go down, okay? So 0, 0 is the vertex. And instead of going 1, 1, I'm just going to go down. I'm going to go down 1, right? 1, 2, I'd go up 4, but now I'm going to go down 4. 1, 2, 3, 4. 1, 2, 3. 3 squared is 9. So going up to 9, I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, it is symmetrical, right? So, you know, the other is true on the other side of this graph. It's symmetrical with respect to the y-axis. And there it is. Okay, thumbs up. Pretty easy. All right.